Hello everyone. Welcome back to my YouTube channel Physics Unlocked. This is Hajra Mughal, and in today's video we are going to explore a fundamental concept in physics using a powerful tool, dimensional analysis. We will be applying this technique to prove the homogeneity of an equation, a crucial property that ensures the consistency and validity of physical laws. So let's dive in and unlock the secrets of dimensional analysis together. Okay, so students, the homogeneity of an equation, we are going to prove the homogeneity of this equation, and this equation is second equation of motion by using the dimensional analysis. So the left hand side contain the displacement, and we know that the dimension of the displacement or a distance is L, and on right hand side it's VIT plus half AT square, and half is a dimensionless constant, so we can omit it. Now the equation will become VIT plus A and T square. So the dimension of the velocity is Lt minus 1. The dimension of the time is t. The dimension of the acceleration is Lt minus 2. And the dimension of t square will be t square. So base same, power will be added. Minus 1 plus 1. So it will become t power 0. And plus Lt minus 2 and minus 2 and plus power 2, so it will again become minus 2 plus 2, so the t having 0 power and the t having 0 power, so it will simply look like L plus L. Students, one thing which you have to remember, that if I add 10 centimeter plus 2 centimeter, then the answer will be 12 centimeter. The unit will remain same, only the number will be added here. Okay, if I look at here in the dimension, so when you add centimeter into centimeter, the answer will be centimeter. If you subtract it, centimeter into centimeter, the answer will still centimeter. So if you are adding dimension or you are subtracting dimension, the answer will remain same, the answer will be L. So the dimension of left hand side and the dimension of right hand side are equal, so you will write it simply that right hand side is equivalent to the left hand side. Okay, so students, next equation is the third equation of motion, which is 2as equals to vf square minus vi square. Okay, so again we will take the left hand side, it's 2as, and 2 is a dimensionless constant, so we will omit it because it has no dimension. So the dimension of acceleration and the dimension of distance, the dimension of acceleration is Lt minus 2 and the dimension of the distance is L. So base same, power will be added, so it will become L square t minus 2. This is the dimension of left hand side. Okay, so now the dimension of right hand side is vf square minus vi square. Vf is the final velocity and vi is the initial velocity, so Lt minus 1 square minus Lt minus 1 square. So taking square, so it will become L square t minus 2, and it will become L square t minus 2. Again, that thing which I have explained in the previous slide, that when you subtract two lengths, means 10 centimeter, for example 10 centimeter minus 8 centimeter, then it will be 2 centimeter. Only the number will get subtracted, but the dimension will remain same. There is no change in the dimension. So when you subtract two dimensions, it will be equivalent to that dimension only. So L square t minus 2. So you can see the left hand side is equivalent to right hand side. So you can conclude that left hand side is equivalent to right hand side. So the homogeneity of this equation has been proved. Okay, so the next equation is the equation of the time period of the mass spring system. Okay, so on left hand side we have time, and the dimension of the time is time. Okay, on the right hand side we have a quantity 2 pi under root m upon k. M is the mass and k is the spring constant. Okay, so we will again write that 2 pi is a dimensionless constant, so we can omit it. So the final formula will become under root m over k. So students, we know that the dimension of the mass will be capital M, but we don't know the dimension of the spring constant. So we can calculate it by using the Hooke's law, which is F equals to kx. And if I want to calculate k from here, so it will be F over x. And what is the dimension of F, students? Yes, it's equivalent to MA, and M will be M and A will be L T minus 2 divided by what is x, students? X is the extension that spring has occurred after applying a force, so it is equivalent to the L, because extension has the dimension of the length. So L cancel out, so the dimension of the k will be M T minus 2. Okay, so if I substitute this in this equation, under root m over mt minus 2, so m will be cancel out, and if I take t on the numerator, so it will be t square in under root. Square and under root will be cancel out, then it will become t. So the dimension on right hand side is also t, and the dimension of the left hand side is also t. So this is the dimension on left hand side, and this is right hand side. So the homogeneity of this equation is also proved. Okay, so next equation is the equation of time period of simple pendulum, and we are going to prove its homogeneity by using dimensional analysis. On left hand side there is a time period, and the dimension of the time period is t, and on right hand side we have the term 2 pi under root L over G. And again we will write that 2 pi is a dimensionless constant, so it has no dimension, so we will omit it. So the right hand side will become now under root L over G. Okay, now what is L? The dimension of the length is again length. And what is G, students? G is acceleration due to gravity. So the dimension of G is same as acceleration, which is Lt minus 2. So after substituting this in this equation, so the equation will become under root L over Lt minus 2. So L and L will cancel out. If I take this T on the numerator, so it will become with the plus 2 sign, and the square and the root will be cancel out. So the dimension of the T will become, T. So the dimension on the left hand side is T, and the dimension on the right hand side is also T. So we have proved the dimension of this equation. Okay, so students, next equation is Fc equals to mv over r, and this Fc is known as a centripetal force. So on left hand side we have Fc, which is known as the force. So the dimension of the force is ma. If you know the dimension of the force, so you can directly write it. If you don't know, then you can derive it by using the equation of ma. So the dimension of m will be m, and the dimension of a will be lt minus 2. So the dimension of the left hand side will be mlt minus 2. Okay, on right hand side we have mv over r. So the dimension of the M is M, and V has a dimension L, T minus 1, and R has a dimension L. So if I cancel out L by L, so the dimension of the right hand side will be MT minus 1, which is not equivalent to the right hand side. So what we will conclude, that left hand side is not equivalent to the right hand side. It means this equation is not correct. This equation is not correct because it's not proving the homogeneity principle. So the next equation is E equals to mc whole square. If you know this equation, then you can directly comment on this equation that this equation is wrong, because the original equation, the famous Einstein's equation, is E equals to mc square. The square is only on the speed of light. But if I want to prove the homogeneity of this equation, then the left hand side is equivalent to the energy. And if you know the formula, the dimension of energy, then you can directly write it, or otherwise you can derive it by using the formula of half mv square. And half is a number, dimensionless constant, so it will not affect the equation. So the dimension of the mass is m, and lt minus 1 whole square. So if I write it, m l square t minus 2. So this is the dimension on the left hand side. Now we have a right hand side, and right hand side says that m and c both are in whole square. So the dimension of m is m square, and the dimension of c is l t minus 1. It is also having a square. So m square, l square, t minus 2. So you can see that they are not correct, they are not equal to each other. Then you will conclude that left hand side is not equivalent to the right hand side. So this equation is not correct because it is not obeying the homogeneity principle. Thank you so much for watching. If you found this helpful, please subscribe to Physics Unlocked for more content. Want more questions solved? Let me know in the comments. Thanks again, and I'll see you in the next video.